Hi there, how are you doing today? Namaste, good morning, afternoon, wherever you are. My name is Vishnu Dutt and I work as a network architect in Cisco. And you can see the agenda for today's session. So today we are going to discuss some of the network security principles. And I was just wondering that people might think that why we are learning these SD-WAN sessions, in these security related sessions in SD-WAN. Is it really necessary? And the answer is absolutely it is necessary. If you want to create your own lab, doesn't matter which platform you want to use, EVNG, CML, you should have a fair understanding of network security, especially authentication. Okay. So in today's lesson, in today's class, we will be learning most of the security basics, right? And there are three basic principles of security, which is confidentiality, integrity, and authentication, right? We are going to discuss all three in detail. First of all, we will be discussing that why we are learning security concepts here. Is it really necessary? So yesterday we left the session on this diagram, on this picture, right? And my question was yesterday that if suppose anybody having a device which is SD-WAN device, whether it's a vEdge, vSmart or vManage, whatever it is, and my complete network is running fine, right? With all the edges are up, everything control plane, data plane is up. So can someone with a particular device come and join my network? If he or she can, then there is a problem for that, right? And the reason is if somebody can join, then somebody can disrupt this network also. Whatever I have, this is my complete SD-WAN fabric, right? And if anyone can join with simply having a device, it is not a viable option. So now the point is, what security mechanism SD-WAN solution use to restrict such users, to restrict such devices, right? So we need to understand how we can build these controllers from scratch, right? What security mechanism our SD-WAN solution is using, and what is the way we can bring up our lab, right, when we want to build this solution. Okay, so understanding of authentication part is necessary here. Authentication means the device or the person, whatever he's claiming to be, is actually that person, right? So if I say that this vBond belongs to my XYZ organization, he's just saying it. What are the different ways he can prove that he is from XYZ organization, right? We need to check that. And that is where authentication comes into picture, right? Now, if this device comes and he cannot prove that he's from XYZ organization, then he cannot join this organization fabric, right? Again, authentication is crucial here. So what are the different methods? What are the different security technologies which are involved in authentication? We are going to discuss that part in this section. Majorly, we are going to discuss certificates, but to understand certificates at the first place or authentication at the first place, we need to understand confidentiality as well as integrity. I'm using the terms, I will be explaining them. Because along with this authentication part, along with this device authentication part, we will be discussing TLS and DTLS also. And TLS, DTLS means complete security. And complete security means confidentiality, integrity, and authentication. So for any security, whenever we want to have a security between two devices, to a client and a server, and we want to run some security protocol, we need to consider these three parameters, which are integrity and authenticity. Let's discuss first confidentiality. So here I just wrote basically what are the mechanisms, what are the ways we can achieve confidentiality. So if I explain you the meaning of confidentiality, suppose if I have a message which is written in simple text, anybody can read this, right? And if we send this message over internet, definitely it is passed through various router switches, and anybody can see that if he or she has that capability to see that, right? So it is always good to encrypt this message before sending it. What is the encryption meaning? I will be explaining it, right, when we discuss details of confidentiality. The second part is integrity. The integrity meaning that if I am sending this message, which consists of ABCD, and when it received at the receiver side, it will be intact. Means no other person in the middle can change that message. It is fine that I can encrypt it, but the people on the internet can basically alter this message, right? If they are not able to read it, they can destroy our communication by just altering it. So integrity makes this thing possible, that your message at the receiver side is intact. Okay. Authentication. We will be discussing digital certificate in that. Confidentiality can be achieved through various ways, and we will be discussing that. The terms wise, it is symmetric and asymmetric encryption. So I know that in this audience that there are so many people who have security background, but be here, guys, because you will be learning. For you it is just kind of a brushing up of your security concept. But for other guys who are from routing switching background, data center background, this is going to be pretty interesting thing, believe me. So the first thing, let's discuss confidentiality first. And if time permits, I will combine all these puzzles, so all these pieces in a single point, so that we understand the complete solution. So just try to understand this way, right? We have a big puzzle. We want to achieve security between a source and a destination, right? And I am dividing this puzzle again into three parts, which is confidentiality, integrity, and authentication. So we will be discussing all the pieces one by one. And once all the pieces are done, we will combine them to have the complete picture of the security, right? But it is important to understand the individual components, right? So here, let's start with the confidentiality part first. So suppose this is my laptop and I'm connected to internet, and I want to do a transaction with the bank, and here is the bank server, right? The problem is, if I send any packet over the internet, the threat is that an intruder or a hacker can just see these packets. I do not want to do that. And basically, this is not the problem of what we can say modern world. This has been happening from a longer period of time, or you can see this has been happening since long, right? So previously, what people used to do, they just encrypt this message, and that's what we are doing right now. So let's try to understand what is the meaning of encryption. Okay, so there are three key concepts here: plain text, key, and ciphertext. So the plain text mean whatever I am sending out from my machine, right? First, it's just a plain text, means anybody can read it. Suppose this is A, B, C, D. What I want is, when I send this packet out to this wire, it should be scrambled. It should be in a way that is not readable by others, right? To do that, I have a simple logic here, right? So suppose these are my alphabets, right? And I want to send a message A, B, C, D. So what I will do is, I say that instead of writing A, I will shift to one position left in this alphabet and write A as Z, and writing -1 here because I am shifting one position left. So A will be converted to Z, B will be converted to A, C will be converted to B, and D will be converted to It is simple, right? So instead of sending this message, I will be sending ZABC. You must be thinking that it is very easy to decrypt it, because I just need to say, instead of reading Z, I can have A, right? But the concept here is, this was my plain text. And when I use something, right, I have a formula that if I shift it towards left, it will become ZABC. But if I shift it towards -2, it will be, A will be written as Y, B will be written as Z, and so on, right? So this is plain text. The output, when I implement this value, -1 or -2, will be my encrypted text, which we call as ciphertext, right? And the number which I am using to convert ABCD to ZABC or plain text to ciphertext is known as key, right? So in simple terms, if you have your plain text and if you have key, you can have another message which is an encrypted message, and we call it as ciphertext, which is not readable if you do not know this key, right? If suppose there are two people, A and B, they know what is the key. I would say that the key is -2, right? A understands easily that how I need to encrypt the message, because I just need to shift 2 places towards left. And B knows that if I want to decrypt that packet, I just want to shift 2 places right? So if I have this key value at the receiver end, the receiver can decrypt it easily, right? The whole sole purpose of confidentiality is you are sending encrypted packets which are not readable to other guys unless they have these keys, right? So once again, I am repeating the thing. The message which was in simple text was your plain text. You use key to make it unreadable, and the new message will become ciphertext. It's as simple as that. Now, the algorithm which we are defining here, right? I know this is my key value, but what is the algorithm? The algorithm was, when key value is -1, shift it towards left. Shift 1 place to left. This was my algorithm. This was my key, right? So many cipher algorithms already exist, which are really strong. And if you want to read in detail, I can name some out for you, which are AES, DES, and so many. AES means Advanced Encryption Standard. DES means I just forgot, right? But ES means Encryption Standard. Okay, so I believe that we are on the same page here. What is key? What is plain text? What is ciphertext? Right? And what is the algorithm? So now I ask you a simple question here. Suppose we have 2 guys here who wants to communicate with each other here, right? And they want their message to be secure. So what they need is, they need here a key value and an algorithm, right? If I say my key value is 20-bit long, just like here we have, and my algorithm is AES, and by any means, if I say the same value here also, that here is my key, which is same 20 bits which I was using here, and then I have AES, then for B it is really easy. It is really easy to regenerate that message. Okay, so because we are explaining the concept of key here, I would like to explain basically how key works actually, right? So the primary thing which you have noticed here between A and B is, here is A, here is B. I have suppose key 1 here. If this guy wants to decrypt the message, we should have key 1 here, and it should know that what algorithm I am using for encryption. Suppose I am using AES for encryption. This guy should know that over this communication channel, if this guy use AES, then I will be able to decrypt it, right? Now, if you are looking it closely, then I need to distribute this key to B so that B can decrypt it. And here we are having the same problem, right? So I can do a simple call to this guy B that here is my key, here is my algorithm, and you can decrypt whatever I am sending to you, right? But this should not work in computer cases, right? So what is the mechanism? How we can distribute this key, right? So if these keys are same at receiver, at sender, I'm not discussing how these keys are reaching to B, right? But if these two keys are same, we call such encryption as symmetric. And why symmetric? The reason is we have the same keys. That is it, right? Now it is also worthwhile to understand what is asymmetric encryption, right? And to understand asymmetric encryption, you need to understand two things or two key types, right? Every individual, say this A, if I assign it two values, right? First value is, I would say, public key. And the second value, I would say, private key. These are nothing but just two numbers, right? I am mentioning them with X and Y. So these are not any random number, but these are generated with a proper algorithm. And the logic here is, you would be amazed to see that if I have a message, suppose message M, and if I want to encrypt this message with this value X, right? The resulted message will be, suppose encrypted message, I will write it M dash. Now this will be encrypted, right? But if I pass, and suppose I use the algorithm, say AES, to encrypt this message. At the receiver end, if I pass the same message and decrypt it with Y, it will give me the again same message, which is M. What does it mean? It means that if I encrypt any message with public key, it will be decrypted using private key, and vice versa also, right? What are the use cases? I will be telling you. But for now, just try to understand the relation between public key and private key. I am again repeating. Suppose here is me, right? I have two numbers with me. I am just calling them public key and private key, right? X and Y. If I encrypt a message with my public key, X, anybody can be able to decrypt it using my private key, right? Or vice versa. If I encrypt a message using private key, anybody who has the access to my public key would be able to open it, right? So there is a relationship between this number. But yes, any other number would not be able to decrypt your messages. Okay. So what is the benefit? Now try to understand. With symmetric algorithm, my problem was I was not able to distribute this key one, right? Suppose there are hundreds of machines who want to communicate with me, right? It is not the feasible option to tell everybody that here is, the key one is my key, right? So there must be some suitable mechanism to distribute this secret key, right? So to distribute this secret key, sometimes I use asymmetric keys. And how it happens? Again, suppose I have this A, I have this B, who wants to talk over this internet medium. Guys, this example is going to be very, very important in understanding certificates also. So just pay close attention here, or otherwise just have a look the recording again and again unless you get this concept. Okay. So here A, suppose I have a secret key, which is my secret, right? I have denoted this using the secret, right? My problem is, how can I send this secret key to B? The one simple solution was calling them, which was not a feasible one. So if I want a communication between A and B, and if A decrypt my messages, all my messages using this secret, I would require the same secret here at B also. Otherwise, I won't be able to decrypt this message. It is as simple as that, right? So how we are going to do that? So for that, I will be generating two more numbers at both the sides, right? For A, I will be having two numbers, public key and private key. These are just the number, guys, right? Suppose this is X, this is Y. Similarly, I generate the numbers here also at B. Public key, suppose this is K, and private key. Suppose this is L, right? So as the name indicates, public key can be redistributed because it is public. It can be known by anybody, right? But private key is only for you, and you are not going to give it to anyone, right? And you know one relationship between X and Y also, and the relationship is, if any message is decrypting using X, it can be if any message is encrypting using X, I can open it using Y, right? So there are many mechanisms to distribute these public keys available in digital world, right? So if this public key, I can transport it from here to here, by those means. So I will be having three keys here, right? Public key of B, I will be having there also, right? Which is K. So what I will do is, I will take this public key of K, right? I have this message M, which will be containing my secret key, this one, right? What I will do is, I will encrypt it. I will encrypt this message using public key of B, which is K, and the new message is going to be M dash, which is encrypted one, right? When this message reaches to B, what does B needs to do, right? It needs to again decrypt it using its private key, which is L, right? Because if a message is encrypted using K, it can be opened using L, and we will be seeing the secret here, right? You must be thinking that if I can redistribute this public key in this manner, why can't I distribute this secret key? And there is a difference here. Secret key should be secret. Private key can be known to anyone. Sorry, public key can be known to anyone. Okay. So again, repeating these things, guys, I can create two numbers X and Y, which are related such that if anything is encrypted using X, it can be decrypted using Y, and vice versa, right? But what I want is, I want symmetric encryption. I want to give this secret key to here, right? And what I'm doing is, what I am doing is, I take the public key of B, I encrypt it, and then basically I'm sending it so that B can open it from its own private key, and that is it. Okay. So one more question which should be striking in your mind is that if I have this solution itself, why I am sending this secret key, right? So although I have a great method using public key and private key to encrypt things, right? But this is not feasible always, and the reason is because we have this, and because we are using different keys in here, we call it as asymmetric encryption, right? Because we are using two keys here, public and private. The computation involved in this segment when we use asymmetric encryption is really, really high. And we do not want to overload our laptops or servers with that. And that is why we do not want to use it. We are just using it to just share our secrets. Once secreted as both places, there is no problems, right? We can use the symmetric encryption, which is not that computationally strong, okay? Which doesn't take that much computational power. I'm not sure whether I am making any sense till now, but if you have any question, please do ask. Because these things are really, really important to the second part, which is integrity.
Vishnu, just for my understanding, can you just briefly explain the difference between key and the algorithm?
Okay.
Just a point. Yeah.
Okay, so key is number. Key is just a number because I said that replace the device to negative. Means just if I say this number -2, the algorithm will understand that I need to shift left, right? If I write this again 1 A B C D and this X Y Z, if I write this number, algorithm will understand I need to go to this. Right? This is just a number, but this is algorithm is the whole set of instruction how it is going to do that, right? So if I have a message, if I say key -2, I need to specify an algorithm here, right? That what is this? What is the meaning of this -2, right? This will be calculated by algorithm. Okay.
Can I say algorithm is a function and key is the argument to that? Really?
Yes, absolutely. In fact, you got it correct, right? So if I say this encryption is a function, so I would write key here. This is my function. This is the argument for that. Actually, you defined it very well, actually, and thanks for that.
Thank you. That answers. Thank you.
Okay. So anything else, guys? Rohit?
Yes, we do have few questions now. So we have a question from Srinagar.
Okay.
It is how public key gets downloaded to A. Is it a manual download? I mean, how that is exchanged?
Yeah. So there is a complete infrastructure already there. So don't worry, guys. I will be explaining it to you. Do not worry about it. But for now, understand that we can distribute it. We can distribute public keys very easily, and there is a complete infrastructure already there. Okay. Any other questions which I can take, which you think is very important to take now?
Well, it's related to key exchange only, so I'll post it probably in the group. And
okay, sure. We will be explaining that later. That's fine.
Yeah.
So for now, we are good with the confidentiality part. Let's try to understand integrity now. Right? So here you go. Again, I think you have an idea about this. Whatever I want to send, right? A, B, C, D. It should be received A, B, C, D here. And the receiver is sure. Receiver should be sure that whatever the sender is sending me is exactly this message. And how we can achieve it? This is the purpose of this integrity, right? So that receiver can prove that yes, this is a message sent by sender. Okay, and how can we do that? So you can argue with me that if this message is encrypted, then why do we need integrity? We need integrity because encrypted message can also be altered, right? Suppose I change this message to say ZYXC through any key, maybe -20, right? So this is the encrypted one. But if attacker has an access to that, he just can change it, right? How can I be sure that this is the actual thing which is sent by the sender? So here we have sender, here we have receiver, which is my HDFC Bank server, say, right? So for that, basically, mathematics is important everywhere, and whatever we are learning together all comes under mathematics and advanced mathematics. So here, what we have to achieve this is, so suppose I have a message which is ABCD, right? I pass it through a function, and this is again a mathematical function, which generates a value, say 10101, right? It always generates a fixed value. I am taking example of, say, 1, 2, 3, 4, 5, 6. If this function is always gives me a value which is 8-bit long. Doesn't matter the size of this one. It can be 26 characters, it can be thousands characters. Whatever there is in the message, if I pass it through this function, it will always gives me this 8-bit. But if I change even a slightest of this message, for example, if I write A, B, B, C, yeah, E, okay, and if I pass it again through that function, it will be giving me completely different values. You are getting my point, right? And it is almost impossible. I should not say almost. It is impossible to convert from this message again back to this message. And that is why I'm saying this is one-way function. Okay, how I can use it for the message integrity, that is going to be my next topic. But for now, try to understand that if I pass a message through this function, it will always generate me this value, right? And it is again impossible to generate this value from this one, this number. The second thing is, if it is again impossible to have any different message, say X, Y, Z, anything, which can generate the same number. And if I can generate the same number, then basically my mathematical function is not working right, right? So it is always impossible for any other message, whatever the combinations I try. If this is not ABCD, it is not going to give me this number, right? So the whole sole purpose is what I was explaining here is that there are mathematical functions which are one way, right? Which can generate a fixed value for a particular message. Now let's see how I can use it for my message integrity, right? So suppose I have this message once again, A, B, C, D, right? I pass it through a function, which is a one-way hash function, and it gave me a value called 1010, right? 4-bit long. It depends on the mathematical function you are using, that how much bit value this is going to be. If you want more security, it should be more, right? So what I am going to do is, along with this ABCD, I will attach this hash value, and I'm calling it as hash. I'm not writing 1010, I'm writing it as hash, right? So instead of sending ABCD, I will be sending ABCD plus hash to this guy, right? And tell this guy that the algorithm which I am using, or the hash function I am using, is FX, right? And there are many hash functions available, and most commonly we use secure hash algorithm, or SHA. Comes in variable, in different variation, like 256, 512. These are nothing but the key size. Okay, guys. So if I pass this ABCD with hash function FX, right, it is generating a number which is hash. And now I am not sending my packet alone. I'm sending it with this hash value. When this guy receives this packet with hash, and I think you must have figured out that what receiver will go to check, right? Receiver will divide this number, this packet, into two parts. One is the hash, and other one is the original value. Correct? It will pass this original value with the same function again, because before communication, you know that this guy is going to use SHA, secure hash algorithm. So here, this guy is also using the same function fx or SHA to get the same value, right? Which is 1010 or hash. Now, if these two values are same, this receiver is sure enough that yes, I got the correct message. Am I making any sense, guys? Right? There must be some questions about this, but let's stick to the basics. If I have a function which is one way, I can achieve message integrity. And this is again, we are learning the complete solution in pieces. So there must be so many questions about this, right? I have first of all explained you confidentiality, now integrity. And believe me, these are part of a complete solution. We are just trying to understand the pieces. So first piece is done. Second piece is done. If we understand the third one, then we create a holistic view of this solution, which I don't think is going to happen in today's session because I need to cover authentication part also, right? But I would like to take some questions now. I would like to take some questions now. So moderator means anybody, Saurabh, Punish, Rohit, do we have any questions now?
So we have a request that if you can repeat the hash part from Swaminathan.
Okay, so Swaminathan, it is going to waste time for so many people. I would advise you just go and see this recording once again. You will get to know. Okay?
Okay, and there's one more. Can we skip the like integrity because we have already have the integrity in networking protocol, CRC check, etc. This is from Shrikant.
Yes, this is a really good question. So I'm not talking about applications, that which application you are using, right? If there is a cyclic redundancy check or other algorithm, we definitely skip it. But if you consider some of our protocols, an application, they require this hashing, right? And I agree with you guys that if I attach a hash size here, this is making my packet really long. But if I have a message of 1000 bits, and if I am attaching only 120 bits or may say 4 bits, this is not that great overhead, right? So you need to have the balance between what do you want? You want integrity at the receiver end or not? If you do not want, then we are okay. That's fine. So that's what I said. These are pieces, right? You can remove and create your own solution with the remaining two. Even IPsec does that, right? And I'm not sure whether you are aware of cryptocurrencies, Bitcoin, or how this network works. So guys, if you are aware of hashing, if you are aware of these three concepts, this network on which the Bitcoin or other cryptocurrencies operate is really, really a good thing to learn. Just from point of view that how basically we can transfer, how basically we can have transaction within a second, which is secure, right? So I'm not sure how well versed with you with cryptocurrencies, but whatever the concepts I have told you till now, everything is using they are using there, right? So that their network is foolproof. Okay. So anything else, guys?
Yes, this same question from Arshdeep and Abhay, and is it like, can the attacker replace both hash and original value?
Yes, but it won't be able to because the reason is we haven't completed the picture of the solution. We are just reading we just completed two pieces of it. But definitely, when I explain you authentication and when I combine all these three, then your doubt will be clear that attacker cannot do that. And there is a proper reason. There is going to be proper reason for that. So do not worry. Anything else? Saurabh, Rohit, Punish? Am I audible?
Yes. So there's one more. So we are learning this for authentication and certification. I mean, the purpose of it, right?
Yeah, we are learning it only. No one can when fabric if I build it. what are the security mechanisms there? And the second reason is I want to build my lab, right? And most of the people doesn't want to do that because of certificate thing, right? And I'll explain you, this is going to be one of the most simplest thing. If you go to this recording, if you do not get it, guys, in any solution of Cisco, doesn't matter whether it's belong to security or not. If you are reading SD access, if you are reading SD-WAN or anything, right? If you are into ACIs also, right? There also, first thing you, when you go to the customer environment, he will ask you, we need to install certificate. Are you comfortable in that? Right? I have seen this a lot in my career. So it is better to understand this technology well. And it is simple, right? It's just plain mathematics, very simple. If you don't understand at the first go, just try to repeat this recording as many as time, right? But let me complete the full solution first. We are just complete with two pieces, only confidentiality and integrity. We haven't even touched authentication part. When we complete it, there is going to be an entire solution and all your questions will be answered on your own. Okay. Anything else?
No,
okay.
we are covered for now. Yeah.
Okay, sure. Now, let's talk about authentication, right? This is going to be interesting, another interesting part. What is the meaning of it? Again, I have my laptop A here, right? I have a server here. A bank transaction is going on, right? If I do a bank transaction, suppose I encrypt also, right? I do the hashing also with public key or whatever I have explained to you and send it to this guy. What is the proof that I am actually sending it to HDFC bank server, right? Anybody can come here. Anybody can claim that I am HDFC bank server. What he or she needs to do? He just needs to have server, right? Generate public key, private key. Give this public key to you that if you want to encrypt anything, just encrypt with my public key and I can open it. So your encryption is there, your hashing is there, but there is no proof that you are sending your messages to a correct entity, which is actually HDFC bank. How you are going to make sure that whatever you are, whoever you are sending packets to is actually what he's telling you, right? Did you get my problem? I'm not sure about that, whether I'm talking to HDFC bank server or somebody else. So is there anything which can build that trust between me, my laptop, and this HDFC server? So I always take an example from real life to explain this, right? Because you won't believe me, whatever the solutions we have in security, all are taken from the real life only, right? But the way of implementation could be different, right? So let's try to understand this with an analogy in our real life, from our real life, sorry. So suppose we have Mr. A, right? So he's a good businessman, but recently he moved from his town to a village, right? This village is the new one. So I am naming this person as, say, Mr. Rahul. Okay. Now he wants to set up the same business in this village also, right? Which he just moved. So to set up his business, right? He needs raw material. So what he did is he roam around the complete village, right? And found many person, and he found this one interesting. So we have here, which is Mr. Dutt, say, right? So he is the guy who can supply raw material to Mr. Rahul, who wants to set up the business, right? So Mr. Rahul goes to him and say that I want a raw material of, say, $1,000, but I cannot give you $1,000 in advance. I can give you only $100, and I want raw material worth of $1,000. This guy will say, no, I cannot give you because I do not know you, right? You recently moved in my village. I do not know you. And if I provide you all this raw material of 1,000, I do not know whether you will provide me the money back or not. But the problem of Mr. Rahul is genuine, right? He wants its raw material so that he can sell out to it whatever he produced from it and get the money back from the market and give it back. But it is not happening, right? Mr. Dutt is not convinced with these people, with this, with Rahul. He don't want to give $1,000 amount of raw material. So what I am seeing here, there is a problem of trust. Mr. Dutt does not trust Rahul. Rahul does not trust Mr. Dutt. And this is the wholesale problem which we are seeing here also, right? The same problem. A is not sure who SDFC Bank is, whether this one is the correct server or whether this one is the correct server. He doesn't know. Similarly for bank doesn't know who you are, right? So this is a common problem which we see in our daily life, and the common problem name is trust. There is no trust between SDFC Bank server and A. There is no trust between Rahul and Mr. Dutt. Am I making any sense? So how I can solve this problem in my real life, right? So I just need to find a person who know both of them, and that is it, right? So generally, there is a village headman, and suppose this is, say, Mr. Punish, right? Here we have Mr. Punish, and this guy is village headman. Of course, he knew this guy, and I'm not sure why, but he knows this guy also. And now he can do the interesting thing. What he can do, he can just go to Mr. Dutt and tell him, don't worry about Mr. Rahul. I know him personally, right? He's a very good businessman. And you give him $1,000 value of raw material, and definitely he's going to give you back after some time, right? He goes to this guy. He says, Mr. Dutt is a good raw material supplier. Don't worry with your $100 also, right? And you can start business with him. So who is generating the trust between Mr. Rahul and Mr. Dutt? Punish, right? So if we introduce this kind of a person or a server in our digital world also, my problem of trust will be gone, right? And exactly this is what we are doing in our in digital world also. This guy, this guy, Mr. Rahul, is client or my laptop. This guy, Mr. Dutt, is server. And this guy, I think you all have heard about a common term, which is certificate authority, right? This guy who knows both of them, right, is the certificate authority. Okay. So again, I am repeating that this trust problem could be easily be solved if we have one server here who knows both of them and generate the trust between them, right? And this is where your public key infrastructure comes into play. So now let's understand basically what certificate is, what PKI infrastructure is. And I was pretty sure that when we were going into the deep of all these things, I won't be able to combine the complete solution, means complete three pieces together. So let's try to understand PKI today, and after that we will conclude the session with your questions. Okay. So let's try to understand what this PKI infrastructure is. Suppose I have two entities. This is me. This is my laptop, right? And this is the server I have, right? The problem here is A doesn't know the server, server doesn't know A. I want to generate it as trust between them, right? So you are well versed of keys now, right? So I have public key generated for A, right? Which is say X. I have private key generated for A, which is say Y. Similarly, guys, try to pay more close attention to this topic now. This is a digital certificate, what I'm going to explain you, but in very simple terms. But the concept is going to be same if it is ACI, if it is SD-WAN, or anywhere, right? I can generate the same key pair at server side also. Here I have public key, which is say K, and private key, which is say L, right? Now, I have a central authority also with me here, which I call certificate authority or central authority here. So this guy has the whole sole responsibility of giving identity to people or computers. So this guy, suppose this is HDFC bank server, right? This guy goes to him with its public key, right? Try to pay close attention, guys. This guy goes with his public key and with some documents, which proves that this guy is actually HDFC bank server, and those documents could be anything like registration number from the government. This CA will examine the document, and when he confirms, when he is sure that yes, this HDFC these documents belong to HDFC server, what he will do is he will give HDFC server a certificate. Okay. This certificate is nothing. If I go slightly deeper into that, then the certificate authority also has its own public key and private key. Suppose those are N and N. This is public, this is private. So what the CA is doing is, it takes all the information, and this information can be your name, right? Your country, your public key. It will take this document, right? It will use its private key to generate a hash value, which we just discussed, which is say 1010101, right? And it will put this hash value at bottom of this document, just like that it has signed this document with its own private key. So this document will become your certificate, HDFC bank certificate, right? So what is the meaning of it? It is as good as that this is the village headman, which is saying that, okay, you are HDFC bank because I know you. You get the point? So this certificate will go to this device, and what this certificate contains? The certificate contains public key of HDFC server and a little fingerprint of certificate authority signature. And signature is nothing, but it is using its own private key. And guys, pay close attention. I'm not encrypting it with using public key. I'm encrypting this information, name, country, and public key of HDFC bank. Once I am sure this is HDFC bank, I am encrypting it using my own private key. Okay. So this will become the certificate. What certificate contains? Public key and this little signature done by certificate authority, right? So I'm not sure whether you have opened your web browsers or not, and take a look at its security parameters. You will find that there are already some certificates installed, right? Like VeriSign and other larger certificate authority. Suppose this is a VeriSign. right? So what I say, you already have a certificate installed of this certificate authority in your laptop, right? And what that certificate contains, that certificate contains public key of this CA, maybe very sign, right? So two parameters here. One, this guy went to certificate authority give it a certificate which contains public key of this server and this CA's private key signature, right? The certificate authority is well known, and that's why it is already there in your web browser, right? What you have in your web browser, you have public key of your certificate authority. And we also call this as root certificate. Do not go much into the terminologies now. But right now, just try to understand. I'll take another 2 more minutes for you guys. But this certificate authority can give it public key to all the browsers. And as an exercise, you can do it today. You just open your browser. Maybe it's Chrome, maybe it's Firefox. Doesn't matter. You look into these. You will find that there are many root certificates or these public keys available in your browser, right? Now, what is the purpose of everything? When you initiate a connection, when this guy wants to talk to SDFC server, right? As a return back, SDFC server will present its certificates to it. What does certificate contain? Public key of what? The server and the fingerprint, right? Now, the interesting thing is, now the server wants to authenticate. See what we are doing. We are just want to be sure that HDFC bank server is HDFC bank server and not the intruder one. So what this guy A will take, it will take out this public key from it, and it will it will take this signature from here, right? It will decrypt it using public key of certificate authority because it already a public key of certificate authority, right? So what it will see this hash value 101010, the same value, right? If a value is encrypted by private key, it can be decrypted using public key. We are not using it for encryption here. We are using it for authentication. Same thing, different purpose. Try to understand, right? Again, I'm repeating, A wants to communicate to HDFC bank server. The bank server will reply with its certificate. What is the certificate? Which was given to the certificate authority, right? Here we have the certificate. The certificate will contain all this name, private key, everything. But along with that, there is a little signature here, which was encrypted by private key of the certificate authority. Now, because A has public key of the certificate authority, it can open it and get the same hash value, right? So this public key and all the other parameters will going into the same hash function. It will, if it generates the same value, this guy knows that I am actually talking to HDFC bank server because it is signed by the certificate authority, and I have proven that because these two values are same now. I think maybe it is too much for you guys, but the beauty of the recordings is you can listen as many times as you want, right? I think it is, there are a lot of terms, there are a lot of security concepts today, because I want to finish these concepts in only 2 sessions. Otherwise, I won't be able to complete SD-WAN, right? So, but it doesn't mean that I'm not available. If you have any issue, any problem with these concepts, I will be there, right? But request is just try to listen this recording as many times as you want, but be sure on these 3 common principles which we have learned: confidentiality, integrity, and authentication, right? So guys, this complete thing, whatever I have explained you, the certificate authority, how it generates the certificate is called public key infrastructure, because the main purpose is we are distributing public keys, right? Public keys of certificate authority or public keys of servers, maybe client, right? Tomorrow, we will combine all of them together. We will see how all these things are clubbed together in SD-WAN for authentication. We will also try to understand what exactly this TLS and IPsec tunnels are in greater detail, because now we have the firm understanding of confidentiality, integrity, and authentication. With that, I conclude my today's session. Sorry for being, I believe we are over time for, I think, for 6-7 minutes, but we started late also. But now, Rohit or Punish, if anyone has any questions, please ask them to shoot. I am here. Rohit, Saurabh, any question was there?
I think the only question came after that. It's both A and server always have details of CA, correct?
Yes. So basically, if I explain it to you, then it is the server's responsibility to go to certificate authority, right? And most of the times it is a manual process. So if suppose I open a company and I want my company's server to be well trusted, well authenticated, so I will go to the certificate authority. I will say that I am HDFC Bank server. Here are my documents. Please sign it with your private key. It means that certificate authority is going to give me the certificate. But yes, for the client side, if there is well-known certificate authority, the root certificate or the public key of the root authority will be there in the browser. Okay. So what details are signed by private key? It is up to you what details you are taking to your details you are taking to the certificate authority, right? You can. I'm again sharing my desktop. So panelists, I will be requesting you to read the question because now I cannot read the question. So I'll explaining that thing here. So if you are a server, right? What information you can go and sign? Your common name. What is your common name you want to use on the internet? Maybe cisco.com, whatever. You can sign your subject, right? Of course, public key should be there. Otherwise, this infrastructure will be failed. Which country you belong, whatever the parameter, whatever the general parameters you have, you can go with these parameters to certificate authority and prove it that you are the one, whatever you are telling to the certificate authority, you are the one. Prove it through documents. Certificate its own time to prove, to know that you are the correct one. Once it is done, it can sign everything with certificate authority private key and generate a number using hash, of course. Generate a number 1010, whatever the number is, right? So your certificate, this is your information in the certificate, which is in plain text by the way, and here is a small signature, right? Which is the hash encrypted by private key of certificate authority. That is it. Any other questions, guys? Rohit, Saurabh, or Punish?
This one question came from Anush. Once PCA opens the signed content from SGFC certificate using public key of CA, what will it compare it with?
Yeah.
Is it its own certificate details?
No. It's a good question actually. So here is the SGFC server certificate which I just created, which has all this information and this key, right? Now, when it reaches to A, when A wants to talk to this guy, it will be sending it its own certificate. It means this complete thing, right? It will divide it into two parts. This common information, which is in plain text, and this sign by by certificate authority. So as you know, certificate authority's public key is already in your browser, right? So what it will do, this is your common information, which contains your common name, subject, public key, right? And this information is the signature. You have divided this into two parts, so here you are having two parts. So what this guy do here, it will run a hash algorithm here. Simple, right? It will get the same value. It will get the value, say 1, 0, whatever. What it needs to do is, what this signature consists of, right? The CA has also done the same thing. He has done the common things with hash, and then whatever the hash value, it encrypts that hash value with its own private key, right? So this value, this signature, little signature, what these guys are going to do is, they will decrypt it using public key, because it was encrypted. This hash value was encrypted using private key. I can decrypt it using public key of certificate authority. Very simple, right? And once I decrypt it, what I will get this number, which should be the same, right? If these two numbers are same, the meaning of this fact is that whatever the certificate I am receiving, it's not from any intruder. It is it's not from anyone who is not SDFC, you can say, right? If you are receiving this and you have verified it, it must be from SDFC, because a well-known certificate authority has signed the certificate, and I am proving it here, right? Anything else, guys? Any other question?
This one from Pyumbada. Is a client certificate also authenticated by the server in a similar fashion?
It's again a great question. So I kept it simple, but yes, if your application wants that this trust should be built two-way, means client should authenticate servers, servers should authenticate client. There are mechanisms for that also. And yes, many of the application wants this. Any other question, guys?
And one last I have, I think probably you have already answered it. It's from SM. How will the certificate authority knows for sure that the request for certificate is from SDFC bank server?
And that is where I told you that this is absolutely manual. This process is going to be manual and time consuming. SDFC bank doesn't go with only these things. It also goes with certificates, which are the plain paper. So if you want to open a enterprise, right, SDFC needs to register it with government body, right? They can take all those papers, they can show it to the certificate authority, and certificate authority will go and check again, right? Any other person who is not SDFC would not have these documents, because that person is not going to register with the same authorities, right? And that's why we are pretty sure that yes, the certificate which is coming to me, which is signed by the certificate authority, if I am able to verify it, it is from the actual certificate. It is the actual certificate from the server. Okay. Anything else, guys? Anything else? Punish or Saurabh or Rohit? Okay, so it means that we are good. With that, I would like to conclude this session. See you tomorrow. Have a nice day ahead. Bye, everybody.